calculate the value of resistance R in the circuit. Calculate the value of resistance R in the circuit shown in the figure. What would be the potential difference between points A and B? What would be the potential difference, the PD is potential difference between points A and B? First take down the circuit diagram, then we will understand how to proceed. We have a 6-volt source, and then there are a couple of resistances. Ten ohm here. Then we have another source of 2 volt. And we have our unknown resistance Ro, and the value of this resistance is 15 ohm. We have other resistances connected like this. Five ohm, 30 ohm, and this is 0.2 amps. Okay. Here also the current is 0.2 amps. The given circuit is like this: 6 volt, 2 volt, 10 ohm, 15 ohm, R, and then 5 ohm, 5 ohm, 30 ohm. The question is to find out what is the value of R and also what is the potential difference between points A and B. Now we can simplify this circuit by considering the combination of resistances so that we can easily find out the voltage drop across A and B. So first what you do is find out what is the equivalent resistance between the terminals A and B. Now here if I see, you can mark this terminal also as C. So let this terminal is C. Now if I see here 5 ohm and 5 ohm are connected in series, and between B and D we have then 15, 30 and 10 ohm connected in parallel. So if I redraw this part B and D, this part will be equivalent to so this is B, A, D, 15 ohm, 30 ohm, 5 ohm, sorry not 5 ohm, 5 plus 5, that is 10 ohm. This 5 ohm in parallel series, so that is 5 plus 5 will be equal to 10 ohm. Then we have the remaining circuit as it is: 6 volt, R ohm, 10 ohm, 2 volt, 0.2 amps. Now if you see 15 ohm, 30 ohm and 10 ohm are in parallel. So the parallel combination of this will give us the equivalent resistance. 1 by Rp is equal to 1 by 15 plus 1 by 30 plus 1 by 10. That will be equal to 3 plus 1, not 3, first is 2. You take common denominator as 30. Simplify this. 30. So 2 plus 1 plus 3 equal to 6 by 30 or equal to 1 by 5, or Rp is equal to 5 ohm. So the circuit can be simplified now into this form. Ten ohm, B A. Between BA we have Rp, which is equal to 5 ohm. Then we have, okay, we don't have any resistance here, right? No, we don't have any resistance over here. This is just 6 volt, 2 volt and R ohm, and the current through this is 0.2 amperes. The question is to find out what would be the PD between points A and B. So the potential difference between points B and A. PD, potential difference between B and A, is equal to I multiplied by the resistance between B and A. Which will be equal to the current flowing through B and A is 0.2. 0.2 multiplied by the resistance is 5, equal to 1 volts, or PT between A and B. A and B will be equal to minus 1 volt. So if you measure from A to B, you will get minus 1 volt. This is the PT between A and B. Potential difference between terminals A and B is minus 1 volt. Next question is to find out what is the resistance R in the circuit. We know all the other quantities in this loop. We know the voltage sources, and also we know the resistances and currents. Only the unknown is R ohm. So what we can do is apply KVL to this loop. Applying KVL to that loop, we get KVL. Apply KVL, we get start from 6 volt and use the same sign convention. So 6 minus 5 into 0.2, that is the current, 0.2 is the current or voltage drop across 5, minus R into 0.2 and minus 2 minus 10 into 0.2 equal to 0, or this 6 minus 1 minus 0.2 R minus 2 equal to 0. So this will give us 1, 2, 2, that is 5. 6 minus 5 is 1 minus 0.2 R equal to 0, or R is equal to 1 divided by 0.2. R is equal to 1 by 0.2. 1 by 0.2 is 5 ohm. The unknown resistance therefore is equal to 5 ohm. The unknown resistance in the circuit given figure R is equal to 5 ohm. The unknown resistance in the given figure R is equal to 5 ohm. So the only thing in this type of circuit what we need to remember is the complex network. You reduce it into a simple network, a simple series circuit. Combine all the resistances which are connected in parallel and series and reduce the complicated network into simple series network. Once it is simple series network, it's easy to find out the unknown current or unknown resistance. In our case it is unknown resistance.